Greetings and welcome to a lesson on interfaces. Now, prior to this, we've talked about classes and we've talked about inheritance, extends. Now, it's a rule in Java, of course, that you can only extend one thing. Exploding Ball extends GameObject. I cannot extend anything else. However, sometimes you need to have the ability to sort of extend multiple things. It's a very common pattern in, say, game development where you have a game object, just sort of a generic game object. But then some game objects need to be destructible. Some game objects need to be able to move. Some game objects need to do both. So if you can't extend more than one class, how do you achieve this kind of functionality? Well, for that we use interfaces. It's not the only use that interfaces have. We'll talk about another use here in a moment. But basically what an interface is, it's a class light, I suppose you could think of it. The only thing you can define in an interface are the function definitions. So I have public void do damage, int amount, public void explode. For mover, we've got public void move direction, public void jump. Notice there's no implementations. There's no constructor. You cannot create a new instance of a mover. Or I can't create a new instance of a destructible. An interface, you cannot have an instance of an interface. An interface always has to be attached to another object. And so the idea here is that I've got behavior. I'm defining behavior. This is the behavior. If something's going to be destructible, it's got to be able to take damage. It has to be able to explode. I am saying that if something is going to be a mover, it has to have the behavior of being able to move in a direction, and it has to have the ability to jump. That's what I'm saying with an interface. An interface is a way of saying, I have these sort of sub-behaviors that I need this object to do. So for my exploding ball here, it extends game object. That's the only thing it's allowed to extend. But then I am saying that it implements the behavior of a mover, and it implements the behavior of something that is destructible. Whereas an oil barrel just implements the behavior of something that is destructible. All right, let's take a quick look at some syntax before we move any further on. First, the syntax for declaring something as an interface. You use the interface keyword instead of the class keyword. That's pretty much it. So we've got public, interface, destructible, and then you define the functions. Remember, we are not implementing the functions. So I have the public void do damage int amount, and then a semicolon. There are no curly brackets. You only ever use curly brackets when you are implementing the function. We are just simply defining what this function or this method should look like. Same thing for mover. Got public interface mover, and then the method definitions, not implementation. You cannot implement anything in the interface. We do that when we actually go to implement the interface. So we can see the full syntax here. Public class oil barrel extends game object. The extends always has to come first. If you are doing inheritance, if you are inheriting from another object, you have to extend that first. So oil barrel extends game object, and then if you have interfaces, you implement them. So implements destructible. Now, when you implement something, you are forced to do the actual implementation of any methods defined in that interface. What that looks like, let me comment this out here real quick. if I don't have that code implemented, I get red squiggles of doom, and if I mouse over it, it is complaining that OilBarrel must implement the inherited abstract method destructible.doDamage and destructible.explode. So it's saying this is an invalid class definition because I've implemented something, I'm implementing an interface, but I haven't actually implemented the interface. Now it's worth noting that many IDEs will give you the ability to do this quickly. If I mouse over OilBarrel, say that 3 times real fast, one of my options is going to be a quick fix, and if I click on that, I have these options here, which includes implement all abstract methods, make the class itself abstract, which means I can't actually create an instance of it, or add unimplemented methods. The option I did, by the way, was implement all abstract methods, which automatically put in the @override class name, and then, well, of course, these weren't commented out, but it automatically put in this throw new unsupported operation exception, not supported yet. It's a pretty quick way of getting your interface methods, the skeletal outline of them, put into your code nice and quick. A quick note about annotations. This @override is what's called an annotation. It's like a directive to the compiler saying, hey, I've got special instructions regarding this. @override is saying there must be a super implementation of this or super definition of this method that I am overriding. It's not mandatory. You do not have to worry about annotations, at least not as far as we're going with Java in this class. You do not need annotations. You will get some yellow squiggles of warning saying, hey, I would really like it if you added this annotation here, but it doesn't have to be there. Taking a look at Exploding Ball, we can see that it implements 2 things. If you've got more than one interface to implement, you just separate them with a comma. Implements mover, comma, destructible. And we can see that, yep, there's the implementation of the mover methods. Now, what does this look like when we actually go to use those? Let's take a look at main. So showing off polymorphism, again, because that's a really important concept to understand, I've got an array of game objects, 4 elements, and I'm filling up all 4 elements here. Now, these first 2 lines are pretty standard, right? It's a game object, so I am saying index 0 equals new game object, index 1 equals new game object. So far, so standard. Indices 2 and 3 are a little bit different, though. I'm saying new exploding ball and new oil barrel. Remember, when you extend something, when you inherit from another class, you are that class. So exploding ball extends game object. That means that means exploding ball is a game object. Oil barrel is a game object. That means if I have an array of game objects, I can store, well, a game object in it, or an exploding ball, or an oil barrel, and it's perfectly fine with that. That is the polymorphism. Now, this does cause some interesting issues. Let's look at these commented outlines of code. Now, we would expect line 12 here to not work. Index 1 is a game object. A regular old game object doesn't implement anything. It does not know about the destructible interface, and so it makes sense that this would be an error. Method do damage is undefined. But what about index 2? Index 2 is an exploding barrel. Exploding barrel does in fact implement destructible. So why isn't it working? Well, again, remember, when it comes to polymorphism, what are you referencing this object as? This array is an array of game objects. That means regardless of what they actually happen to be, I am referencing them as game objects. Game object does not know about do damage, therefore line 13 fails, because I am currently referencing it as a game object. Well, how do I reference something as an interface? Like, can I do that? How do I know? Well, thankfully, there's a really easy way to check to see if something implements an interface, or for that matter, extends another class, and that is instance of. The instance of keyword requires an object on the left, an object on the right, and it will look at those two and say, hey, are you an instance of this? So if I was to say go array 0 instance of, go array 3 instance of game object, that would return true, because an oil barrel extends game object, therefore oil barrel is a game object. That's obvious. That's why we can put it in this array to begin with. But we can also use that to check for interfaces, because if something implements an interface, it is also an instance of the interface. So if I check if goArray index 2 instance of mover, which exploding ball implements mover, so that will return true, and then I can just do a cast. So I've got mover temp equals dynamic cast. Ignore that. Dynamic cast of go array to mover, and then I can use temp.jump and I will jump. And this block here won't cause any problems because, well, index 0 is not an instance of mover, and so that will return false, and I'll never hit these lines of code. Which is good, because if you don't do that, and you try to cast something that can't be cast that way, well, you get an exception error. Let's run this and see what happens. So we get a report of our object IDs here. We get an object jumped. And then we get an exception on line 26. Because, again, index 0 is a game object. It doesn't have mover implemented, so trying to cast it as a mover fails. But casting index 2 as a mover succeeds, well, because it is one. That is why, by the way, you should always check for instance of before doing this type of casting. And yes, I am aware that line 29 violates that. I mainly just simply wanted to show an alternate way of doing the casting, but if I was being properly thorough, this would be contained either inside a try statement or inside of an if testing for instance of. But notice here I'm not using a temporary variable. Here I'm saying mover temp equals go array dynamic cast to mover, but I'm not doing that here. I'm saying take a go array index 3, dynamic cast it to destructible, but then by encapsulating all of that in an additional set of parentheses, basically everything inside that set of parentheses is now going to resolve to reference GoArray index 3 as a destructible, which means I can now call do damage on it. With the expected results. If line 29 confuses you, don't worry about it. This is the more normal way, I would argue, of taking a game object, or I'm sorry, taking an object, casting it to an interface, and then calling a method off of that interface if you do not know ahead of time, does it or does it not implement this interface. So, quick recap. Public class game object, just your run-of-the-mill ordinary object, or run-of-the-mill class. Public interface destructible, public interface mover. These are declaring interfaces. Remember, an interface can only define methods. It cannot implement them, and it cannot have attributes. It cannot have values like this. And yes, I know I haven't explained that. I'm not going to. Think about it, and you should be able to see what I'm doing here. And then finally, we have exploding, or let's do oil barrel first, because that's a simpler one. Oil barrel extends game object and implements destructible. So it acquires everything from game object and then this additional information. And because it implements destructible, we have these two methods defined, or implemented, I should say. Exploding barrel, or exploding ball, extends game object, implements mover and destructible, so therefore it has these 4 overrides defined or implemented. Should go without saying that language sometimes on this can get a little casual. Again, to be strictly correct on the words that I'm using, this is defining the method. This is implementing the method. An interface defines methods. And when you implement the interface, you must also implement the method. Interface methods are called like any other, but you do have to make sure that you've got the right reference. Okay, let's talk about the assignment. So there is assignment main and assignment car. Should be fairly obvious, but do not modify this block of code. Instead, we're going to use interfaces to implement sorting behavior, which is a very common thing to do. Array lists have the ability to call .sort, which will sort the array list. However, if you have an array list of objects, this will not work, because there is no predefined sort method for an object. I mean, think about it. How would you sort this game object? By the ID? By the name? What about this one? Should I sort by damage or speed? Or should I sort by health? Because remember, we also still have these values over here as well. So yeah, there's no predefined, preset way to sort a game object. And so what you need to do is you need to implement comparator. I have not shown this. Again, this is deliberate. this is one of those research points. The knowledge, what you need, is on W3 Schools. You can find this on W3 Schools. You don't, again, wherever you get your information is fine as long as your code works. So you need to implement the comparator interface on assignment car. So this needs to implement the comparator interface. You will then, down here, where the comments are, we'll need to call classiccars.sort and then reprint out the list, I would assume just using this little code block right here. Now I want to take a moment to talk about lines 20 through 35. Regardless of what you personally think about generative AI, especially as programmers, you have to deal with it. Like, you will be asked to use generative AI in your job, most likely. Or you will encounter somebody on your team who is using generative AI. There are proper uses for this. This is an example of that. So I use this prompt, generate an array list of 10 classic cars using assignment car, to generate this block of code right here. Sometimes in programming, you just need test data for whatever reason. You need test data to run through your code to make sure things are implemented correctly, or you want to do some stress testing and you need 5,000 things to enter into the code now. It doesn't actually matter what this data is. Like, it just has to be somewhat sensible data that you would expect to see. I mean, maybe there could be various reasons as to why you don't want to use live data. Maybe you don't have the actual data yet. You know what it should be, but you don't have the files yet. So this is a demonstration of what I would consider appropriate use of generative AI in development. I need some cars and year numbers to be able to test whether or not the sorting is working as intended. It is worth noting, I have no idea if these are correct, and I have no idea if the dates line up correctly. Always be aware when using generative AI that it hallucinates and it will make stuff up. It's also worth noting that I'm not using the generative AI for any critical parts of the code. See the current state of Windows 11 as to why that is a very bad idea. But that is enough soapboxing for me. It's just, I will always be transparent when I am using generative AI, and in this particular scenario, I think this is an acceptable use to generate the data. It's better than me saying a series of Model A, Model B, Model C, and car year of being 1900, 1901, 1902, so on and so forth. This is at least a little bit more interesting. And with that, good luck with the assignment, and I'll catch you on the next video.